Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, the concept of continuity is very simple if we have a good knowledge of limits of a function. If we are given a function f of x and we draw the graph of that function, and the graph is unbroken, there is no jump in the graph from one point to another point, then we say that that function is continuous. Mathematically, we say that a function f of x is continuous at a point A if it satisfies three conditions. The first condition is f of x must be defined at a point x is equal to A. It means that in the given function, if we plug in x is equal to A and simplify this, there must be some answer, some value, and that value will not be equal to plus or minus infinity. The second condition is left hand limit of that function at the given point must be equal to the right hand limit of that function at the given point, which means if I obtain limit x approaches to a negative f of x, that must be equal to limit x approaches to a plus f of x. The third condition is the value obtained from the limits must be equal to the value of f of a. In other words, we can write that as limit x approaches to a negative, f of x is equal to limit x approaches to a plus f of x from condition number 2, and now this must be equal to f of a. So if a function satisfies these three conditions, we say that the function is continuous at a point x is equal to a. If one or more than one conditions are failed, then we say that the function is not continuous. Look at the graph of this function. Now continuity says that at a point A, the value of f of A must be some real number. And if we take left hand limit from this side and right hand limits from this side, they will approach to the same point. So the limits from left hand side will be equal to the limits from right hand side, and they must also be equal to the value of the function at a point A. Now from the third condition we can see that left hand limit are equal to right hand limits, and when left hand limits are equal to the right hand limits, we say that the limits of the function exist. And in that case, we write limit x approaches to a f of x. So if we only prove that limit x approaches to a f of x is equal to f of a, it means the function is continuous. If a is the rightmost endpoint of the graph of the function f of x, then how to find limits of this function at x is equal to a? In this case, we can see there is no graph on this side. The graph is only at the left hand side of a. So we can only take left hand limit from this side. We can only take left hand limits of the function f of x at a, and if left hand limit is equal to f of a, we will say that the function is continuous at that point. On the other hand, if a is the leftmost endpoint, then we can see there is no graph at the left hand side of a. The graph is only on the right hand side of a. So we can take right hand limits of that function at x is equal to a. And if right hand limits is equal to f of a, we will say that the function f of x is continuous at a point x is equal to a. To check the continuity of a function at closed interval a comma b, we must satisfy these three conditions. And you can see the first condition says that we need to determine that the function is continuous at the leftmost endpoint. The second one says that the function must be continuous at the rightmost endpoint. And the third one says that the function must be continuous at each point between the open interval of a and b. As it is a hard and difficult task to determine the continuity of the function f of x at infinite number of points between a and b, so a simple procedure is given in this hint. If we are given a function and closed interval and we want to determine the continuity of this function at that closed interval, simply differentiate that function and then look at this interval. If there is no point which I put in f dash and I get infinity or minus infinity, we don't have such a point, it will mean that the function f of x is differentiable and hence it is continuous on the closed interval a comma b. In this example, we shall determine whether the function f of x is continuous at x is equal to 2 or not. Let us draw a real line and represent 2 on this real line. On the left hand side of 2 there is 1 and on the right hand side of 2 there is 3. We can see to find the left hand limit, all values on the left hand side of 2 are less than 2. So that is why in each question to find the left hand limit, we shall use that part of the function f of x for which x is less than 2. To find the right hand limit, we can see all values on the right hand side of 2, they are greater than 2. So we shall remember that in each question, to find the right hand limit, we shall use that part of the function for which x is greater than 2. And we can see at x is equal to 2, to find the value of the function at 2, we shall use that value of the function f of x for which x is equal to 2. Now let us check the first condition of continuity, which says that at x is equal to 2, the value of f of x must be defined. So at x is equal to 2, the value of the function is 3x. We substitute 2 in this function and after simplification we get 6. So we can see that f of 2 is equal to 6, which is not equal to plus or minus infinity, and it means that the value of the function f of x is defined at x is equal to 2. Hence, the first condition is satisfied. To prove the second condition, we shall prove that left hand limit of this function at x is equal to 2 is equal to the right hand limit. Let us find the left hand limit of this function, which can be written as limit x approaches to 2 minus f of x. And now we know that we shall substitute the value of f of x for which x is less than 2. So that is why we write limit x approaches to 2 negative and the value of the function f of x for which x is less than 2 is x square plus 2. Now we substitute x is equal to 2, and after simplification we get 4 plus 2, which is equal to 6. Let us find right hand limit now. So right hand limit can be written as limits x approaches to 2 plus f of x, and we shall use that part of the function f of x for which x is greater than 2. So just substitute the values of the function f of x for which x is greater than 2, and that value from the given function in this question is x cubed by 2 plus 2. Let us substitute the values. So we have 2 cube divided by 2 plus 2. This is equal to 8 divided by 2 plus 2. And if we simplify, this is equal to 4 plus 2, and now this is equal to 6. We can see that left hand limit is equal to right hand limit because both are equal to 6. So second condition is satisfied. It means limit exists. The third condition is that left hand limit will be equal to right hand limit, and this must be equal to the value of the function at 2, and we can see that all of these three are equal to 6. So the third condition is satisfied. In other words, this can be written as limit x approaches to 2 f of x, that is equal to f of 2, which is equal to 6. So since all three conditions are of continuity are satisfied, so this implies that f of x is continuous function at x is equal to 2. There are three types of discontinuity: removable, jump, and infinite discontinuity. If we look at the graph of a removable discontinuous function, at some point there will be a gap, a hole in the graph of that function, due to which the function will be discontinuous and is called a removable discontinuous function. Mathematically, the left hand limit and right hand limit at that point will exist, so and they will be equal. So the limit will exist, but if we find the value of the function at that point, let us say f of a, then the limit will not be equal to f of a. If we look at the graph of a jump discontinuous function, it will be broken. In other words, it will approach to some point and then there will be a sudden jump from that point to a new point from which the graph will start again. Mathematically, left hand limit and right hand limit at that point will exist, but they will be different from each other. The graph of an infinite discontinuous function will approach to some point, but it will never touch that point. Mathematically, left hand limit of that function will be undefined. Our right hand limit of that function will be undefined, or both will be undefined. In this example, we are given a function which is equal to this thing if x is not equal to 5, and this one if x is equal to 5. In other words, if x is greater than 5 or less than 5, its value is x square minus 25 divided by x minus 5. When x is equal to 5, its value is 7. So the left hand limit of this function can be obtained by using this procedure, and we can see it is 10. The right hand limit can be obtained by using the same procedure, and we can see the right hand limit is equal to 10. Now, left hand limit is equal to right hand limit, which means that the limit of the function exists, and that limit of the function when x approaches to 5 is equal to 10. Now at x is equal to 5, the value of this function is 7. It means f of 5 is equal to 7. Now from this and this one, we can see that the value of the function at a point 5 is not equal to the limit of that function when x approaches to 5. So the function is not continuous, and this type of discontinuity is called a removable discontinuity. It is called a removable discontinuity because we can convert this function to a continuous function by defining a new function capital F of x, which will be equal to the same value of the function when x is not equal to 5, but here we shall use that value of the function which we get from the limits. So at x is equal to 5, its value will be equal to the limits of that function. And now this capital F of x is a continuous function at x is equal to 5. In example 3, we check the continuity of this function at x is equal to 0. Let us see the first condition of continuity. At x is equal to 0, the value of the function is 2x plus 3. Plug in x is equal to 0 in this function, we get that f of 0 is equal to 3, which is not plus or minus infinity. Hence, f of x is defined at x is equal to 0. The first condition is satisfied. To find the left hand limit, we can see that for x less than 0, the value of this function is again 2x plus 3. Now applying the limits and simplifying, we get that left hand limit is equal to 3. To find the right hand limit, we see for x greater than 0, the value of the function is x plus 1 whole square plus 3. Using this value and applying the limits, we get that right hand limit is equal to 4. Left hand limit is 3, right hand limit is 4. So they are not equal. It means limit x approaches to 0, f of x does not exist. So the function is not continuous. Since left hand limit and right hand limit both exist, but they are not equal. So this function has a jump discontinuity at x is equal to 0. In this last example number 4, we have a function f of x which is equal to 1 over x square if x is not equal to 0. It means that if x is less than 0 or x is greater than 0, f of x is 1 over x square. If x is equal to 0, f of x is equal to 1. So we can see that f of x is defined at x is equal to 0 because f of 0 is equal to 1. To find the left hand limit, we use the value of f of x, which is 1 over x square, and applying the limit. So we get 1 over 0, which is equal to infinity. Similarly, to find the right hand limit, we get that this is equal to infinity. So the limit does not exist and the function is not continuous. Since both limits are undefined, so we say the function has an infinite discontinuity at x is equal to 0. That's all.